Now, let's take a look at probability. What is probability? Probability is a measure that is associated with how certain we are of outcomes of a particular experiment or activity. Experiment. An experiment is a planned operation carried out under controlled conditions. If the result is not predetermined, then the experiment is said to be a chance experiment. Flipping one fair coin twice is an example of an experiment. A result of an experiment is called an outcome. The sample space of an experiment is the set of all the possible outcomes of that experiment. Event. An event is any combination of outcomes. Uppercase letters like A and B represent events. For example, if the experiment is to flip one fair coin, event 8 might be getting at most one hit. The probability of an event A is written PA within parentheses. Now, probability is basically the relative frequency of that outcome. Probabilities are between 0 and 1 inclusive. That is 0 and 1 and all the numbers between these two values. A probability cannot be less than 0, nor can it be greater than 0. It can only be any number between 0 and 1. If a probability is 0, that means that event will never happen. If a probability is 1, that means that event will always happen. And any value between that just tells us how much probability there is of that event happening. Let's take a look at an example. Let's see the example of tossing one coin into the air. Now, what would be the possible outcome of tossing one coin to the air? We could get heads or we could get tails, right? That's the two possible outcomes. This is also called the sample space. This is our sample space. It's the only two possible events of flipping a coin. Now, how many events do we have? In this case, 2. That's the total number of events that we have. Probability is basically defined as the number of ways it can happen divided by the total number of outcomes. In this case, how many ways can we get ahead? Only one way, right? One way divided by what is the total number of outcomes, or the sample space? 2. That is the total number of outcomes. And the probability, sorry, let me put this as number. The probability is 1 divided by 2.5. That is the probability of getting ahead. And the same goes for the probability of getting tails, because there's also one possible way to get tails. Let's look at another example. Let's say we have a sample space where we have males and females. We have 43 males, 57 females. Now, what is the total outcome in this case? Well, the total outcome is the sum of these two, 100. That is the total outcome. Now, we want to know what is the probability of getting a male in this sample space. Well, the probability is the number of possible ways it can happen. We have only 43 males, so only 43 ways of that happening in our sample space, of course, divided by the total number of outcomes, 100. we get 0.43. The same thing for the female. What is the probability of getting a female? Well, probability is how many ways it can happen? 57 ways we can get a female, divided by the total number of outcomes, and we get 0.57. These are the probabilities of getting male or female in this sample space that we have here. The conditional probability of a given B is written like this: P A vertical bar B. P A given that B happen is the probability that event A will occur given that event B has already occurred. And the notation for this formula we can see down there, that is the notation, and that is how we calculate the conditional probability. An example of conditional probability. We have a sample space of right-handed people and left-handed people, males and females. Now we want to know the probability of that the person is right-handed given that is a male. That is, I chose one person out of this pool of people. I chose one person and the person turned out to be a male. All right, that probability already happened. That event already happened. Now what is the probability that that person is right-handed? That's what we want to know here. This event already happened. I picked one person and it was a male. Now I want to know what is the probability that that person is right-handed. Applying the formula, probability of A and B. What is the probability that the person is right-handed and male? Well, first we have to see in the graph the probability that is right-handed is these two right here. So let's put that in one color right here, one color, yeah. And that is a male. Let's put it in a different color right there. So if you see what is the intersection between this, that is a male, and this, that is right-handed. The intersection is this cell right here, right? This is the intersection, and this is the probability A and B. So I'm gonna go ahead and put that A and B, 43. Okay. And then I'm gonna put this to normal, okay? And then what is the probability of B? That is the probability of male. The probability of male is basically this right here, 43 plus 9. That would be the probability of male total. So I'm going to divide this 43 plus 9. And there it is. This is the probability that the person is right-handed given that is a male. Same thing here. What is the probability that the person is female given that is left-handed? So same thing. I chose one person, that person is left-handed. Now I want to know what is the probability of that person being a female. Well, the first thing is, what is the probability of both female and left-handed? The probability of female is basically this right here, and the probability of left-handed is basically this. The intersection is this cell, 4. So I'm gonna put 4, and then B. What is the probability of B? Left-handed. What is the probability of left-handed? 9 plus 4. That is the probability of left-handed. 9. I'm gonna sum this to 9 plus 4. And there you go. That is the probability of female given that is left-handed. And what is the probability that it is left-handed given that it's a female? Well, same thing. We already know that the intersection of left and female is 4. Left and female is 4. Okay. And what is the probability of female? This is the probability of female. 44 plus 4. So I'm going to go ahead, 44 plus 4. That is the probability of the person being left, given that it's a female. And this is how we calculate conditional probability. Another example. Let's calculate what is the probability of choosing a male and a female. What is the probability of me choosing one person here out of this space and that person being male and female at the same time? To figure this out, what we have to do is find the intersection between the two. What is the probability of being a male? The probability of being a male is this. This is basically the probability of being a male. And the probability of being a female is this. Now we see that there is no intersection between the two. These cells do not intersect with these cells right here. So the probability of me picking a person that is both male and female is 0 in this case. Why? Because they do not share, these two do not share any characteristics. They are both independent. In this case, we say that they are independent events. So the probability of being male and female at the same time is 0. But now let's see what is the probability of a person being male. This tells us what is the probability of being male or female. So if I pick a person, what is the probability that is a male or a female? Could be any of the two. Could be only one, but could be any of the two. So the probability of being male is this, and the probability of being female is this. So that's basically the sum of both. The probability of male, we know that it's a male is 52. Here we see the sum 52 divided by the total number of sample 100. So here we're going to put probability of being male 52 divided by 100. Okay, so that's the probability of male. Now the probability of female 48. So same thing, 48 divided by the total number in the space. We see that the probability of choosing a male or a female is 1. Why? Because this covers our entire space, our entire sample space. If I pick one person here, that's a male, right? If I pick one person here, that's a female. Here, male. Here, female. So it doesn't matter which one I pick, it will have these characteristics, male or female. So the probability is 1. It will always happen. That's what this means. Probability 1, it will always happen. Probability 0, it will never happen. Now the probability, what is the probability of it being male and being right-handed? Well, for this we need to calculate the intersection. The probability of being a male is, we already know, it's 52 divided by 100. Okay, that's the probability of male. What is the probability of right-handed? Actually, is the intersection. Sorry. So, what is the probability of being male? I'm gonna highlight this. What is the probability of being right-handed? This. We see that the intersection is right here in this cell, 43. So the probability of being male and right-handed is 43 divided by 100. That is the probability of picking a person that is male and right-handed. So for female and left-handed, it is exactly the same. The probability of female is this, and the probability of left-handed is this. The intersection is this cell, 4 divided by 100. The probability of it being a male or left-handed is basically the sum of both. So the probability of male, let me remove this highlight. The probability of male is 52 divided by 100. The probability of left-handed is this, 13 divided by 100. So here is divided. Okay, so this is the probability of a person being male or right-handed, male or left-handed. So we're basically adding the two, applying this formula, adding the two probabilities, and this is how you calculate probabilities given a sample space.